Good morning students. Class 12th, chapter number 6, applications of derivatives, lecture number 1 homework and lecture number 2. I am going to discuss two questions from the homework part. The first question is question number 8. In this, a balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters of gas per second. You see, cubic centimeter per second is given. That means rate of change of volume with respect to time is given as 900 cubic centimeter per second. Clear? We have to find the rate at which radius of the balloon increases. That means we have to find out dr by dt when the radius is equal to 15 centimeter. This is what we have to calculate. Now just to see, as it is given sphere shape, applying the volume of sphere, we'll write d by dt of 4 divided by 3 pi r cube equals 900. Right, let us differentiate it. 4 upon 3 pi into r cube will be 3r square dr by dt equals 900. Now we can write dr by dt will be equal to 900 multiplied with 3 divided by 4 pi into 3r square. 3 and 3 can get cancelled. We can place the value of r. R is given as 15 centimeter. 900 divided by 4 multiplied with pi multiplied with 15 multiplied with 15. We can solve it now. 15 1 ja, 15 6 ja and 0. 15 1 ja, 15 4 ja. 4 and 4 getting cancelled. So we are left with 1 upon pi. Now it is rate of change of radius. So centimeter per second. This is how you are going to solve question number 8. I hope this is clear to you. Just identify what the value is given and what you have to calculate. And using the concept, you can just find it. Strictly increasing functions. So we will discuss strictly decreasing functions as well. In strictly increasing functions, we have a function f of x is said to be strictly increasing function in this interval if we write x1 is less than x2. That implies f of x1 is less than f of x2. For all x1 comma x2 that belongs to the interval in which the function is defined. Clear? So this can be much clear through a graph. We'll definitely be going with the graphs. Thus fx is strictly increasing on AB if the values of fx increase with the increase in the value of x. Let us just see the graph of it. So just look here. I have drawn a function or a curve y equals f of x. The interval is from A to B. This is x1 and this is x2. You can clearly see x1 is less than x2 and the values of f of x1 is less than f of x2. Right? This value is lesser than this value. Correct? So we can say in these cases the graph is of a strictly increasing function. You can see it is increasing. Right? So we'll now discuss the condition for strictly decreasing function. In strictly decreasing function, a function f of x is said to be strictly decreasing function on the interval a comma b if x1 is less than x2. It implies f of x1 is greater than f of x2. So realize the change here. There it was f of x1 less than f of x2 and here it is f of x1 greater than f of x2. Why is it so? Your x1 and x2 belongs to this interval only here. So let us just draw one graph and understand it. So look here on the graph. In the graph I have taken one function. This is y equals f of x. The interval is from a to b, and we see x1 is less than x2, but the value of x1 is greater than value of x2, greater than value of x2. Hence we see the graph is a decreasing function, right? It is like starting from a, if we start, it is going to decrease towards b. Correct? As we increase the value of x, the function of, or the value of the function decreases. These are known as strictly decreasing functions. Now there is a theorem. If f is a continuous function on interval ab and differentiable on the open interval ab, then f is increasing in the interval ab if f dash x, that means the first order derivative of f of x, greater than 0 for each x belonging to a comma b. So let us just suppose x1 and x2 belonging to the interval a comma b. Right? Now we know that it is a continuous and differentiable function. According to the mean value theorem, we know that f dash c will be equal to f of b minus f of a, which is x2 minus x1, divided by x2 minus x1, b minus a. Here f dash c is greater than 0. Correct? So we have to prove that it will be increasing function. So if this is greater than 0, I can say f of x2 minus f of x1 is greater than 0. Solving this, if we add both the side f of x1, we get f of x2 greater than f of x1, or we can say f of x1 is less than f of x2. So we see if f dash x is greater than 0, if we are taking this condition, f of x1 is less than f of x2. This was the condition. If I draw a graph, suppose if it is like this, so if I take this as x1 and this as x2, you see this is an increasing function. F of x1 is less than f of x2. Hence the condition is this also. We can check, like whatever function is given, we can differentiate it and can check whether it is greater than 0 or not. Clear? Similarly, the other proofs can be done. Now let us go to how to solve the questions on increasing and decreasing functions. So the first question is, show that the function f of x 3x plus 17 is increasing on R. R is the set of real number. So one thing that I just told is, you can find the first order derivative, which will be equal to 3, and it is greater than 0. Hence the function is increasing on all x that belongs to capital R. Another way that you can do this question is, just take x1 and x2 belonging to R. Right? Now if we do that, we will write, we'll assume x1 less than x2. Now we have to get this function, right? So first of all, we'll multiply both the side with 3. We get 3x1 less than 3x2. Adding 17 on the both side of the equation, we get 3x1 plus 17 less than 3x2 plus 17. So this is what f of x1 less than f of x2. Help you with a rough diagram. Suppose we have a curve, okay, and I take this as x1, this as x2. You see f of x1 is less than f of x2. This is an increasing graph, increasing function, right? Hence from this you can say that it is an increasing function. Let us go to another question. In question number 3, function given is sin x, and we have to check the function is increasing in 0, pi by 2 and decreasing in pi by 2, pi. 0, pi by 2, everybody knows it is the first quadrant where all the trigonometric functions are positive and they increase. So now we will have the differentiation of sin x as cos of x, and we can say cos of x increases in the interval 0, pi by 2 because it is a first quadrant. If we check for second, it is second quadrant where cos is negative. So we will write f dash x is negative. That means cos x is negative in the interval pi by 2, pi. Hence it is a decreasing function, because our f dash x, which is cos x, will become less than 0 when x belongs to the interval pi by 2 comma pi. Clear? Hence it will be a decreasing function. In this question, we have to find the intervals in which the function given by 2x cube minus 3x square minus 36x plus 7 is increasing and decreasing. So how to do the questions where it is asked to find the intervals, right? Let us first differentiate it. F dash x will be equal to 6x square minus 6x minus 36. Clear? To find the critical point, we will equate it to 0. We will have x square minus x minus 6 equals 0. Clear? This can be further factorized as x square minus 3x plus 2x minus 6 equals 0. We can take x common, x minus 3 plus 2 common, x minus 3. So we have two factors as x minus 3 and x plus 2. Solving it, we get the value of x as 3 and minus 2. Now we will form a number line. On the number line we will represent these. Clear? So suppose this is a number line. So we have to plot minus 2 is suppose here and 3 is here. Clear? So see, we have divided the number line in 3 parts. First, second and third. We will check less than minus 2. Clear? So minus infinity we call it. Minus infinity to minus 2. Just put any value from this interval in your f dash x. So let us just try that. F dash x is, or you can form out a table in which you can just write the values whether increasing or decreasing. I'll show you at the end how to do that. So first of all, in this interval, let us take the value as minus 3. We are going to put in this. Clear? So 6 into minus 3 whole square minus 6 into minus 3 minus 36. Solve it. 6 multiplied with 9. Minus and minus will be plus. 6 3s are 18 minus 36. 9 and 6 will give us 54 plus 18 minus 36. So just observe carefully. When you solve it, what will you get? The answer as greater than 0. Hence in this interval it is increasing function. So one interval we have got minus infinity to minus 2. Clear? In the second interval, minus 2 to 3, we will again place a value between this interval in the f dash x. Let us solve it. So f dash x is 6 x square minus 6x minus 36, and we have to put a value from minus 2 to 3. Let us take it at 1. So when we take it, we get 6 into 1 whole square minus 6 into 1 minus 36. So just see, you get 6 minus 36. The answer you are left with is negative, which is less than 0. So from minus 2 to 3, the function will decrease. In the third case, which is 3 to infinity now. Just look, 3 to infinity. So we will again place any value from 3 to infinity in the function 6x square minus 6x minus 36. So from 3 to infinity we can take any. Let us take 4 or 5 or anything. So let us take 4. 6 into 4 square minus 6 into 4 minus 36. What we get? 6 into 16 minus 6 4s are 24 minus 36. We will get it as 96 minus 24 minus 36. Solving it, we get 96 minus 36 and 20. We get 60. Then the answer will be greater than 0. Hence in the interval 3 to infinity the function is increasing. So we will form a table like this. We'll write all the intervals that we have got. So we got from minus infinity to minus 2, as you can see in the first part. It was coming as greater than 0. So it is increasing. We'll write. So f dash x is greater than 0. Hence the nature of this will be increasing function. It is increasing. Then minus 2 to 3. When we checked, we got negative answer which was less than 0. So the nature is decreasing. And the last one 3 to infinity, we were again getting greater than 0. Hence it is increasing. So we got the intervals in which it is increasing and it is decreasing. We will use the term strictly as we're not including 0 here. If we would have included 0, that means equal to sign also have come in the inequality. We have just said increasing, decreasing, right? So these functions are strictly increasing or strictly decreasing. So this is how you are going to solve the question whenever intervals are asked to be given in which the function is increasing or decreasing. Let us solve another question now. This is question number 8 of exercise 6.2. The function given is y equals, I can separate the powers and write it as x square into x minus 2 whole square. So we have to check whether it is an increasing function. Let us differentiate it. So what will be y dash equal to? X square as it is, differentiation of x minus 2 whole square will be 2x minus 2. Then plus x minus 2 whole square as it is, differentiation of x square is 2x. Now just see in the complete, we have 2x into x minus 2 common. What we are left inside? Here we are left with just x and plus x minus 2 here. Solving it, we get 2x into x minus 2 into 2x minus 2. Equating it to 0 for critical points, we will get x as equal to 0, x as equal to 2 and x as equal to 1. We will just plot these on the number line, suppose 0, 1 and 2. So you will have the intervals as minus infinity to 0, 0 to 1, 1 to 2 and 2 to infinity. Clear? Now in all these 4 intervals, again you will be forming the table as we have done in the previous question and putting the values in between from the intervals. In the function which is y dash, or I say f dash x, you have to check whether it is positive or negative. And then you can decide in which interval it is increasing, in which interval it is decreasing. Solving this in the notebooks, at the end you have to specify which are the intervals in which it is an increasing function. Clear? It is identical to the same question actually that we have done previously. You can just refer to that and complete this. Let us start the next question. In this question, y equals 4 sin theta upon 2 plus cos theta minus theta is an increasing function of theta in the interval 0, pi by 2. Close intervals. So we have to prove it that it is an increasing function. Let us first find dy by dx. In the first one, we will use quotient rule, or because it is just c, with respect to theta, we will differentiate as the parameter is theta here. So doing that, we will get 2 plus cos theta whole square, 2 plus cos theta as it is. Differentiation of 4 sin theta will be 4 cos theta minus 4 sin theta as it is. Differentiation of 2 plus cos theta, 2 differentiation will be 0 and cos theta it will be plus sin theta. So it will become plus 4 sin square theta minus 1. Let us take the LCM and solve it. We will get C 8 cos theta and then plus 4 cos square theta plus 4 sin square theta minus 2 plus cos theta whole square divided by 2 plus cos theta whole square. Solving it, we get 8 cos theta. Now for sin square theta plus 4 cos square theta, you know the identity, sin square theta plus cos square theta is 1. We will get 4 only. Minus 2 square is 4 minus cos square theta. Then we will have 2ab, right, which is 4 cos theta. So because it is a negative sign outside, all will become negative. So we will get in the denominator we have the same term 2 plus cos theta whole square. So what we will get is, I am writing here on this side, 8 cos theta minus 4 cos theta is 4 cos theta. Correct. 4 and 4 are getting cancelled here. Minus cos square theta. Divided by, we have 2 plus cos theta whole square. Now we can take cos theta common. We have 4 minus cos theta inside the bracket divided by 2 plus cos theta whole square. Now just look carefully. 4 minus cos theta, this is always going to be positive. Yes, because cos theta value will be from -1 to 1 only, and that is going to give us a positive answer. This term 2 plus cos theta whole square, because it is a square of something, right? If negative number also comes, then also we are going to get positive only. So this is always going to be positive. The only thing on which our dy by d theta is dependent is cos theta. Yes, and cos theta in the interval 0, pi by 2 is positive. So you can write cos theta is greater than 0, greater than equal to 0 in the interval when theta belongs to 0, pi by 2 in the closed interval. Hence it is an increasing function, which we have proved. As you can see, 0, pi by 2, cos becomes 0 also. Hence I am using the greater than equal to sign with it, which shows it is increasing, not only strictly increasing. Clear? This is how you are going to solve the questions of this exercise. So in the homework of the exercise 6.2, you are going to do question number 2, 4, 6th, 7th, 10th and 11th. Do these questions and come up with the doubts. So for more videos like this, subscribe the channel, add Quark, and keep liking the videos.